Assalamualaikum and good day everyone. I am Nurhata G. Samad and this time I'm gonna discuss the impulsive motion. So what is impulsive motion? Impulsive motion is a term that is used to describe or quantify the effect of force acting over time to change the momentum of an object. Also, it is represented by the symbol J or joules and usually expressed in newtons second or kilograms meter per second. Impulsive is also called impulsive force. Impulsive is defined by the third edition of Hanyang as a strong but short-lived force that two colliding bodies exert on each other. In mathematically, it is defined by the following integral. Integral sign equal to force and time derivative. In other words, the impulse delivered by an impulsive force on a body it is equal to the integral of the force 1 the duration of the collision. If we substitute force equal derivative of pressure over time from the definition of a momentum, we can transform the integral into this. The derivative of pressure over time R provides a biphasic signal that can be used to evaluate acute directional changes of contractility. Our next is average force. The word average here is used to indicate that this is not an instantaneous or precisely measured velocity. Therefore, the average force is equal to the mass of the body multiplied by the average velocity of the object over the defined time. More often than not, the force at each individual moment during a collision is not known. In this case, the average force is more useful. Average force bar equal 1 over time integral time to 0. Average force time derivative equal 1 over time integral equal 1 over time. This relation gives us a quick estimate of the average magnitude of the impulsive force occurring during the collision, instead of trying to map out its rate change throughout the period of time during which the collision occurred. The SI or standard units for the average force are newtons, while the units for impulse are newton equal second or kilograms meter per second. The next one is the formula for the average formula. Therefore, the mass of the object multiplied by the average velocity over the definite time is equivalent to the average force. For a particular interval of time, t, the force will be described as the frequency of change of momentum. It is difficult to determine the rate of change if the time interval is small. Over a period of intervals, t, the rate of change of momentum is the average force mathematically. It is given as this formula. And this is our example problem number 1. A dog of weight 12 kg chases a car for 14 seconds with a velocity of 16 meters per second. What will be the average for the dog? Our solution is the mass given here, letter M equal 12 kilograms. The dog average velocity or V average equal 6 meters per second. The time or T equal 14 seconds. So now this is the formula average for equal mass final velocity minus initial velocity over time. So 12 times 6 minus 0 divided by 14 seconds. So 12 times 6 is 72 kilograms meter per second. So 72 kilogram meter per second divided by 14 seconds is equal to 5.142 kilograms meter per second squared equal 5.142 newtons. So therefore, the average force will be 5.142 newtons. And our last example, problem number 2, a boy throws a bowling ball having a mass of 8 kg. Ball rolls with a velocity of 4 per second for 3-second period. Find out the average for applied. Our solution is the following parameters are given. Mass of the ball is 8 kg. Initial velocity is 0 m per second. The final velocity is 4 meter per second. The time is 3 seconds. The average force is substituting the values in the formula. We get average force equal 8 times 4 minus 0 over 3. So 8 times 4 is 32 kilogram meter per second. So 32 divided 3 is 10.66 newtons. Thus, the average force applied will be 10.66 newtons. So that's all. Thank you.